Hello everyone. Ako rin yung English. Hello everyone. My name is Yulian Francisco. My name is Golden Sentinel. And we are Group 1. We are here to discuss the tracing patterns, tracing an arithmetic sequence, determining the opportunity, and determining an arithmetic sequence, and the sum of the terms of the given sequence. First, tracing patterns. Before we go on to discussing tracing a pattern, first example, what is a pattern?
A pattern refers to a regular or predictable arrangement of elements, such as numbers, shapes, or colors. Patterns can be based on various rules, such as arithmetic sequence, geometric sequence, and repeating sequence.
Arithmetic sequence. An arithmetic sequence is a pattern where the next term after the first we use a constant common difference, where the common difference can only be either additioning or subtracting. Example, find the pattern of given sequence 2, 4, 6, 8. Solution. As you can see on each term that the pattern we use to get 2, 4, or 6, 8 is by adding the first term by 2. So the pattern of the sequence is adding 2 constantly each. Next, geometric sequence. In geometric sequence, the pattern where the next term after the first we use a constant common ratio. Common ratio can only be either multiplication or division. Example, find the pattern of giving sequence 2, 4, 8, 16. As you can see, each term that the pattern we use to get 2, 4, or 8, 16 is by multiplying it by the first term by 2, so the pattern of the sequence is 2x.
Repeating sequences. A repeating sequence has a pattern where the given order is being constantly repeated on a certain rule. It can either be numbers, shapes, or elements. Example, find the pattern of the given sequence. Examples, red, blue, green, red, blue, green. As you can see, each term that the pattern we use to get the value of the next term, red, blue, green, red, blue, green, is by repeating the order of the sequence constantly.
Arithmetic progression. Adding a fixed constant common difference, or also known as CD, to each term to get to the next term. For example, 2, 4, 6, 8. Now, geometric progression. You add a fixed constant common ratio, or known as CR, to get to the next term. For example, 2, 4, 8, 16. Now, repeating patterns. Repeat a sequence of elements in a regular order. For example, red, blue, green, red, blue, green.
4. Formula-based pattern. Use a mathematical formula to generate each term in sequence. 5. Algorithmic patterns. Use a set of rules or algorithms to generate each term in the sequence.
For better understanding, we will make each an example of problems. First, let's start with the formula-based pattern problem. Find the next three arithmetic value of the sequence with the given formula a sub n is equal to a sub 1 plus the quantity of n minus 2 times 3, where a sub 1 is equal to 10 and d is equal to negative 2. Upon unsolving the problem of finding the next three arithmetic value, we would end up with a sub 2 is equal to 10, a sub 3 is equal to 8, and a sub 4 is equal to 6. So, secondly, algorithm pattern problems. Find the fourth, seventh term value of the Fibonacci sequence. Fibonacci sequence has a rule. In order to get the next value of the term, you add the two previous values together to form another. Let's try to solve until the seventh term of the Fibonacci sequence. So we would have 1, 1, 2, 3, 3, 5, 8, and 13. Since the problem stated find the 4 to 7 term value of the Fibonacci sequence, so the answer of the problem is 3, 5, 8, and 13. Next, let's illustrate an arithmetic sequence.
An arithmetic sequence is a sequence of number in which each term after first is obtained by adding a fixed constant number to the previous term. This fixed constant is called the common difference. In simpler terms, it's a sequence where you add or subtract the same number to get the next term. For example, 2, 4, 8, 11, 14, and so on is an arithmetic sequence because you add 3 to get to the next term.
Let's try to solve the 4 given problems on finding their common difference. On the first problem, we are given with a sequence 7, 9, 11, 13, and 15. So how do we find the common difference? Simple, we would just subtract the second term and the first term.
9 minus 7 is 2. So the common difference of this problem is 2.
Second problem, we will use the same process again. A sub 2 minus a sub 1. 10 minus 5 is 5. So the common difference of this problem is 5.
Same process again on the preceding number, and the answer of number 3 is negative 4 and 4 is plus 12. Now let's discuss on how to determine the arithmetic mean and term of an arithmetic mean, sum of terms of a given arithmetic sequence. Arithmetic mean, also known as average, is calculated by adding up all the numbers in a set and then dividing by the number of items in the set. Here is the formula for the arithmetic mean. Let's have an example problem. In between 60 and 70, find the two arithmetic mean. Bring out the formula. A sub k is 70 because 70 is the biggest number. A sub n is 60 since 60 is the lowest number. On the problem, there's only given 4 terms, so k must be 4 and n is what? Simplify both sides. 12 divided by 3 is 4. With this value, this will represent as our common difference. Now let's add 60 plus 4 is 64. 64 plus 4 is 68. 68 plus 4 is 72. The problem stated the arithmetic mean is in between 60 and 72, so it must be 64 and 68.
Now, n term of an arithmetic sequence. The n term of an arithmetic sequence is a formula that allows you to find the n term of the sequence. The formula for the n term of an arithmetic sequence is a sub n is equal to a sub 1 plus to the quantity of n minus 1 times d. Here is a given example. Find the next 3 terms after the first if a sub 1 is equal to 6 and d is equal to 7. First, the formula a sub n is equal to a sub 1 plus to the quantity of n minus 1 times d. Simplify all of them, and the answer of the given problem is 13, 20, and 27. Now for the last, sum of an arithmetic sequence. Sum of an arithmetic sequence. The sum of an arithmetic sequence is the sum of all terms in the sequence. So, let's try to solve this. What is the sum of 1, 2, 3, 4, 5, 6? Simple. Let's just add them up. So the sum is 21. Let's try this problem. What is the sum of the first 100 term if a sub 1 is equal to 10 and d is equal to 3? Let's try to solve. 10 plus 3 and... what? I don't get it. But what if I told you there is a shortcut on this problem? Yes, you are right, with a formula. But which one is it? But if you pay attention, the formula 1 is suitable for the problem, since the problem has terms, common difference, and a sub 1. Let's simplify. Then the sum of the problem is... That is all. I hope you learned something for today. Bye-bye.